Welcome to Math Challenge 442. In Math Challenge 442, we are given a circle. O is the center of the circle. CB is the diameter which is produced to point A, and AP is the tangent. We have got the length of the tangent and the length of AC, and we have to find the radius of the circle. And not one, we will show you two different methods to solve. Not one method, but two different methods. For school exams, junior and senior Olympiads, and competitive examinations, Math Challenge 442, we have to find the radius of the circle, and we shall do it by two different methods. This is the first method where we will not be using any chord, secant, or chord tangent formula. We will not be using chord, secant, tangent formula. Any secant, tangent formula, chord, tangent formula we will not be using. So without using any chord, secant, tangent formula, this is the first method to find the radius of the circle. Join OP. O is the center of the circle and P is the point of contact of the tangent. So join OP. Since radius OP is perpendicular to tangent AP, radius is always perpendicular to tangent. So radius perpendicular to tangent, that means APO is a right angle triangle, because OP will be perpendicular to tangent AP. So this angle P will be a right angle. So triangle APO will be a right angle triangle. So look at the blinking right angle triangle. The right triangle, triangle APO, you can see the triangle blinking. AO is a hypotenuse opposite to angle P, which is 90 degrees. AO is a hypotenuse, and this hypotenuse is equal to 5 up to AC plus the radius R. AO will be up to AC, it is 5 units. Then from C to O, it is radius. So AO hypotenuse 5 plus R. AP, the altitude, which is a tangent, is given 10 units. And OP, which is a base, is a radius. OP is a radius, that is R. So in this right angle triangle, we have got AO hypotenuse 5 plus R, AP altitude 10, and OP base R. So in the right angle triangle, AO square, that is hypotenuse square, will be AP square, that is altitude square, plus OP square, that is base square. Pythagoras theorem. We are employing Pythagoras theorem. Hypotenuse square is equal to altitude square plus base square. So 5 plus R whole square, that is a hypotenuse square, is equal to 10 square, that is the altitude square, plus R square, which is the radius square. So 5 plus R whole square is equal to 10 square plus R square. Expand 5 plus R whole square. 5 square, that is 25 plus R square plus 2 into 5 into R, 10R is equal to 10 square will be 100. 100 plus R square. R square will cancel on both sides. 25 will go to that side. You will get 10R equal to 100 minus 25. 10R equal to 75. R equal to 7.5. So the radius we got was 7.5 units. What we did, since the radius is perpendicular to the tangent, we took this right angle triangle, and using Pythagoras theorem, we found that R equal to 7.5 units. Now we will see another method. Now the second method is a shortcut method. It is a shortcut method because we will be using chord, secant, tangent formula. There we used only Pythagoras theorem in the first method. Here we will be using chord, secant, tangent formula. Let us see the second shortcut method. AB is a secant. It cuts the circle at 2 points C and B. From the external point A, The secant cuts the circle at C and B. So the segments are from the external point AC and AB. AC is one segment which is outside the circle, and AB partly inside and partly outside. So AB is a segment and AC is a segment from the external point to the 2 points of intersection of the line with the circle. AP is a tangent. It touches the circle at only one point P. Secant cuts the circle at 2 points C and B. Tangent will touch the circle at only one point P. It will have only one point of contact. And the segment is AP, the tangent. So by rule, AC into AB, AC from A to C and from A to B, AC multiplied by AB will be equal to AP square. AC into AB is equal to AP square. AC, that's a part of the secant outside the circle, and AB, the full secant, both inside and outside the circle, that is from the external point to the first intersection point, and from the external point to the second intersection point. AC into AB is equal to tangent square AP square. Now, using this relationship, we shall find the radius. So we got the relation AC into AB is equal to AP square. AC, the length is 5 units given. AB, which is AC, that is 5 units, plus the diameter. AB is AC plus the diameter, that is 5 plus 2R, and AB, the tangent, is given 10. So substitute the value, all the values in AC into AB equal to AP square. We get 5 into 5 plus 2R equal to 10 square. AP, the tangent, is 10, AC is 5 units, and AB will be 5 units plus the diameter 5 plus 2R. So substitute all the values in the relation 5 into 5 plus 2R equal to 10 square. Now from here we can find the value of R. So we got 5 into 5 plus 2R equal to 10 square. So multiply 5 into 5 25, 5 into 2R 10R equal to 10 square 100. 25 transpose to that side. 10R will be 100 minus 25. 10R equal to 75. R equal to 7.5. The radius is 7.5. The same result we got earlier. So there are two methods to solve this problem.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.